Everybody, in this video, I want to do some more work with mixed numbers, and I really want to focus on adding and subtracting mixed numbers. Now, we've already talked about multiplying and dividing mixed numbers, and that's pretty straightforward. With multiplying and dividing mixed numbers, the way that you need to do it is to convert them to improper fractions and then follow the multiplying and dividing rules. Now, for adding and subtracting mixed numbers, there's two strategies we can use. One, we can do the same thing we did for multiplying and dividing and convert them to improper fractions. So I'll show you that first. But there is a way to add or subtract in mixed number form, but it requires borrowing and carrying, which can be a little tricky with fractions. So we'll do both examples here, and you're welcome to use either strategy. So strategy one. So your first strategy is to convert the example to an improper fraction and then follow the regular rules, just like we did for multiplying and dividing. So for example, let's say I'm taking 2 1/4 and I want to add it with 3 5/8. Well, I can convert those over. Let's see, 4 times 2 is 8 plus 1 is 9, so I get 9/4. And then 8 times 3 is 24. And 24 plus 5 is going to be 29. So 29. And now you can see it's just a regular problem that we're used to. And we're going to go ahead and add or subtract using our regular adding and subtracting rules. So in this case, you do need common denominators. So our LCD here is going to be 8. So we want to make sure that both of our values here are 8. Now the 29 is fine because it already has the 8, but the 9/4 does not. So I am going to just take a second and convert this one over. I would have to multiply everything by 2, and that would give me an 18 there. So I have 18 over 8 plus 29 over 8. Okay, now I can just go ahead and add my numerators. And I have 47 over 8. I would want to check to see if this is reduced or simplified, and it is. So I'll let you check that at home. But if you try to use some prime factorization here, you're going to see that you really can't do anything with that 47 and break it down. Now, a lot of times when we start with mixed numbers, though, we tend to like our answer in the same format. So I am going to go ahead and change this improper fraction over. 8 times 6, 8 times 6 is 48. That's too big. I don't know what I was thinking. 8 times 5 is 40. And that would be 7 when I subtract. See, we all make silly mistakes sometimes. And I get here my answer of 5 7/8. So I'm able to go ahead and just add by converting over and then using my regular rules. And subtraction works the same way as well. So let's maybe do one example here. So 7 1/5 minus 5 2/3. So I can convert these over first. 5 times 7 is 35, plus 1 is 36. And then here, 5 times 3 is 15, plus 2 is 17. Now, if you think about your LCD here, you are going to notice that it is going to be 15. So again, you can try that out at home, but I do need to change both of these fractions over. And you may have to do a little bit of work off to the side. So I have 108 here. Here I'm multiplying by 5. So I have 85. And I have 108 minus 85. Now 108 minus 85. Let's see, I get 3 and 2. So I get 23 over 15 for my final result. And I can go ahead and convert this over as well. So 15 goes into 23 only one time. And I have 8 left over. So my answer is 1 and 8/15. And of course, you do want to make sure everything is simplified as well. Okay, so nothing really new here, and this strategy always works. So if you're stuck and you're not sure what to do with mixed numbers, just convert them to improper fractions, and you can always do calculations that way. It always works. The only downside is that sometimes these numbers can get quite large. So you can see that I did have to do some work off to the side. So it can be a little bit tedious, but it always works. So the second strategy is to use carrying and borrowing. So I'm going to use the same examples here. And I'll do some extra ones too, because this one's a little bit more tricky. So here I have 2 1/4 plus 3 5/8. So I'm not going to convert to an improper fraction. I'm going to actually use the mixed numbers, but I still need to have common denominators when I add or subtract. So I still need my LCD here, which is 8. And what I'm going to do instead is I actually just convert the fractions over, not the mixed number. And then this one's all set. So this problem becomes 2 2/8 plus 3 5/8. Now, a lot of times when we're adding like this, it is helpful to do it vertically. So I have 2 2/8 plus 3 5/8. And I'm going to go ahead and just add. So I'm going to add my fractions first. So I do 2/8 plus 5/8. Well, 2 plus 5 is 7, so this is 7/8. This is still a proper fraction, so it's fine. And then 2 plus 3 is 5. Now you do want to make sure that this fraction is simplified, which it is. So sometimes you still have to check the final answer. But that's it, I'm all done. So I convert just the fraction part over, and then I go ahead and line them up vertically and add. Now let me do another example of one where you actually have to carry, because that's where it gets a little bit different. All right, so let's do, how about 7 4/5 plus 2 3/5. Actually, let's do that one. So I already was starting with common denominators here just to make my life a little bit easier to show you guys, but you would always want to make sure you have common denominators first. And like I said, I think it's easier to do this vertically, so I'm just going to go ahead and line it up. Now you're still going to add your fractions, and then you're going to add your whole numbers. So I already have my common denominator, so I have 4 plus 3 from the numerator, which is 7. So I have 7/5, and then 7 plus 2 is 9. Now this is almost all set, but we have a problem here. My fraction is not a proper fraction like it was in the last example, so I do need to change that over. So you're going to take that 7/5 and just do a little bit of work off to the side. We're going to change this over. So I get 1 2/5. So what ends up happening here is my problem now becomes 9 plus 1 2/5. So I take that 7/5 and I convert it over. Now I can add my whole numbers. 9 and 1 is just 10, and then I have 10 2/5 as my final answer. So that's how you can add mixed numbers while they're already in the mixed number format. So you still have to have common denominators. You add your fractions and add your whole numbers, but you have to watch out for improper fractions. If they are improper, they need to be fixed and then everything recombined again. So that's how you can add. Let's try some subtracting. All right, I'm going to do the one I did before. So 7 1/5 minus 5 2/3. All right, now you still need common denominators. So my LCD here is still 15. So I'm going to take the 1/5 and convert it over. And then I'm going to take the 2/3 and also convert it over. Times 5. So here I have 3/15 and here I have 10/15. So my problem becomes 7 3/15, oops, 15ths, minus 5 10/15. And again, I want to set this up vertically. It's just much easier. So I have 7 and 3 over 15 minus 5 and 10 over 15. Now, if you look out and you just have a regular subtraction where your numerator on the top is bigger than your numerator on the bottom, like let's say this was 13, then you can just do 13 minus 10 is 3, and you're all done. Everything works out. But I don't have that here. I have to actually borrow because I can't do 3 minus 10. So to borrow, we do take 1 from the 7, but this doesn't become a 13. I have to think about how many parts are in the whole. And here I have 15 parts in a whole. So I'm actually going to take that 3 and add 15 to it. So you add whatever your denominator is. So this becomes 18 over 15 now instead. So now I do 18 minus 10, which is 8, and 6 minus 5, which is 1. Again, you do want to make sure that you're simplified there. 8 over 15 is simplified, but you can see how borrowing is a little bit tricky. So when you borrow, you're not just making the numerator change by adding a 10 to it, you're actually adding whatever the denominator is. So it does get a bit messy there. If you have to borrow. So let's try. All right, let's do this one. So 6 and 3/5 plus -9 and 7/10. Now here you're probably saying this is an addition problem, but because we're adding with different signs, we end up subtracting. So it's still a subtracting problem. Now you do want to convert over. So I see I have a 10 here and a 5 here. So my LCD is going to be 10. So I'm going to take that 3/5 and convert it over to denominator of 10 first. So I have to multiply it by 2. My problem becomes 6 and 6/10 plus -9 and 7/10. Now here, again, I have different signs. So even though it's adding, we're actually subtracting. And be careful when you set things up vertically. We are subtracting, but pretend like that negative isn't there. Notice that 9 is bigger than 6. So that 9 has to go on top. So it's 9 and 7/10 minus 6 and 6/10. Now this one works out nicely because you have a 7 minus 6, which is normal. 7 minus 6 is just 1, so I don't have to borrow here. And 9 minus 6 is 3. So my answer is 3 and 1/10. But we have to be careful. 9 is bigger than 6 and it was negative. So technically this is -3 and 1/10 instead. I'm just going to do one more example with you guys here of this strategy. So 15 minus 4 and 1/3. So again, we have a whole number here. So I have 15 minus 4 and 1/3. Now, this one's kind of weird because I don't have other fraction, but I still need common denominators, and I have to borrow here because I have like 0. So what happens is when you have no fraction, you do have a fraction, it would be 0 parts out of 3. So whatever your other denominator is fine, but you have 0 of them. So now you do have to borrow. So I can't do 0 minus 1. So I take 1 from the 5, I make it a 4. But here, notice my denominator is 3. So I'm going to take my numerator and I'm going to add 3 to it. So my new fraction becomes 3 over 3. 3 minus 1 is 2, so this becomes 2/3. 4 minus 4 is 0, so my answer is 10 2/3. So if you want to borrow with mixed numbers, it's totally fine. You just have to be careful because when you borrow, what you're adding is not 10, it's whatever the denominator is. So that's what makes it a little bit trickier, but you can see it can be faster because you're not converting back and forth to improper fractions. So like I said before, you're welcome to use either strategy that you like. It really doesn't matter to me. So whatever one that works better for you, you can feel free to use that strategy. Okay. One more example I want to do here, just to kind of also refresh our brains a little bit, is to think about our number line one more time. So let's practice graphing some of these mixed numbers as well. So maybe I want to graph the numbers 1/2, 3/4, negative 2.5, positive 4, and 5/6 on a number line. And I'm going to do this one a little bit different than I've done before in the past. And I want to do it by estimating here. So notice that I have some positive, some negative. So I go up to 4 and 5/6 and down to negative 2.5. So I'm going to go up to 1, 2, 3, 4. Let's make this a little bit longer. 5. I'm going to go down to negative 1, negative 2, and negative 3 here. Now, when I've graphed with fractions before, I've really gone very detailed, right? We're going to break it up into how many pieces are the denominator. So really the most detailed thing we could do here is to make everything be a common denominator and use that as our units. But I just want to estimate here and get a rough idea of where these values are on the graph. So let's just think. Now, 1/2, this is a proper fraction, right? So we know it's going to be between 0 and 1. And it's a half, so it's halfway between 0 and 1. So 1/2 is going to be about right here. Now 3/4 is also a proper fraction. So I know it's also between, it's positive, so positive 1 and 0. But I have 3 out of 4 parts filled in. So just think about this. 3 out of 4 parts. Well, half of 4 would be 2, right? So 2 out of 4 parts would be half, and I have more than that. So this is going to be a little bit past that halfway. And there's 3/4. Now, negative 2.5. So here's negative 2, but I also have an extra half. So I'm a little bit past negative 2. So my negative 2.5 is going to be down here. And finally, 4 and 5/6. So think about that 5/6. You have 5 out of 6 pieces shaded in. That's almost the whole thing, right? 5 out of 6 is almost the whole. So you're going to be close to the 5. So 4 and 5/6. Okay. So it's a good idea to be able to kind of start estimating what our values are going to be here when we're graphing and when we're doing our work as well. So for example, kind of going back up here, right? If I think about this, well, 1/3 is only 1 out of 3 pieces shaded in. So that's not a lot. So 1/3 is pretty small. It's almost 0, right? So this is about 15 minus 4, which is 11. Now, if you look at our answer was 10 and 2/3, which is close to 11. So it does make sense here. So let's look at this example here as well. Let's think about estimating these. So 1/5, that's only 1 out of 5 pieces shaded in. That's almost 0. Whereas 2/3, that's over the halfway point, right? 2 out of 3 pieces is almost the whole thing. So that's like a 1. So 5 and 2/3 is closer to 6. And 7 and 1/5 is closer to 7. So this is like 7 minus 6, which is around 1. Notice our answer here is around 1. It's around 1.5. So again, we're estimating. Same thing here, 3/5. Well, that's over the halfway point. If I draw a picture, I have a little more than half shaded in. So this is about 7. And here, 7 out of 10, again, that's over the halfway point. Half of 10 would be 5. So this is about negative 10. So I'm like 7 plus negative 10 is about negative 3. So we can kind of use these ideas here to estimate our answers as well. And again, it just makes it helpful. Okay, so we can also so just a good way just to kind of check and think about understanding what these values represent.